In this video, we'll be discussing limits and continuity in the context of functions of two variables. So first we'll define what limits mean in this context, and also I'll tell you about what we mean when we say that a function of two variables is continuous at a point. So let me start with the definition of limits. So the limit of a function of two variables, f of x and y, as the point xy approaches AB, the point AB, we say that this limit is L, the number L, if for every positive epsilon value there is some positive delta, such that if you are closer to AB with your input values than delta, the function's value will be closer to L than epsilon. Okay, so such that the square root of x minus a squared plus y minus b squared, so such that if this square root is less than delta, then the distance of f of x and y from L will be less than epsilon. Okay, so of course these x, y points have to be taken from the domain of the function. So what you have to imagine is if you look at the xy plane, you have this domain for the function. So this is the domain of f, some region of the xy plane, and you have this point AB, and what you do is you take your xy values and approach this point AB from along some curve, and the function's values will get closer and closer to L, and they can get arbitrarily close for any small epsilon, as you can choose it as small as you can, just be positive. There is a certain sort of circle of radius delta, and when you enter that circle of radius delta with your xy's, the function's value will be closer to L, to the number L than epsilon. Okay, so that's the notion of a limit of a function of two variables. And let me now give you an example. So my question to you is to consider if the following limit exists. So I'll take the xy points and approach the origin for this function, x squared minus y squared divided by x squared plus y squared. So your task is to decide whether this limit exists, whether we have enough information, and the sort of the hint I'm giving you is to consider approaching the origin from two different perspectives, two different curves, along two different curves. One is the x-axis, and the other one is the y-axis. So pause the video and select your answer below. So I hope you paused it and realized that since the limit, since this function approaches different values depending on whether you go along the x-axis or the y-axis, this limit does not exist. So let's imagine that you are approaching along the x-axis when y is equal to 0. So when y is equal to 0, what happens is that these terms are 0. So you only have x squared over x squared, you get 1. So for that value of the function. If your x value is 0, so you are along the y-axis, then you get minus y squared over y squared if x is 0, which gives you minus 1 for the value of the function at the origin. So depending on how you approach the origin, you get different values for the function. Let me just show you what I mean. So here is the plot of this function, and as you can see, if you approach the origin along the x-axis, you are at the height 0, but if you go along the y-axis, you are in this pit and you actually reach the value 0. -1. So that's the story with this function. So let me now give you another example. So that was the first question, and we found that the limit does not exist. So let's go and look at a different example, and decide whether this limit would make sense. By the way, I should have told you that the notation is similar to the one variable case. We say that this limit of f of x and y as xy goes to ab is L. So that's the notation that we can use. Okay, for limits. So that's what I'm using here. So what if we approach the origin along different curves? What happens to this function? X times y divided by x squared plus y squared. So pause the video and select your answer below. Okay, so in this case, I hope you paused it. In this case, what you'll find is if you go along the x or the y-axis, in fact, you get 0 for the function's value. But if you go along the function x equals y, along the line x equals y, you get a half, 1/2 for the function's value. So again, the limit does not exist. Now let me quickly tell you about continuity. So we say that the function that f of x and y is continuous at the point a, b, if the limit of f of x and y as xy goes to ab is indeed the function's value at that point ab. Okay, so this is when we say that the function is continuous, and we'll be mainly considering functions that are continuous. Okay, I hope you enjoyed this video, and I'll see you in the next one.